Ladies and gentlemen, hello and welcome. Coming to you again, not quite live from One Take Studios, where today's topic is rates, ratios, and proportions. These are all kind of lumped together here because there's a lot of overlap between these ideas, but they are definitely distinct from each other. And so I would like to point that out and give us some opportunities to observe some things and try them in context as well, hopefully here. All right, so for starters, a ratio is a comparison of numbers. That's all it is. I know it sounds like a scary word, but it's just comparing two numbers. Now, what could this look like? Well, the first thing that most people think of are fractions. One number on top, one number on the bottom. It's a comparison of those two. For anybody out there who happens to know what slope is, you're comparing how high the particular line goes compared to how far it goes. It's just a comparison. So fractions are a great way to write ratios. Sometimes they are written with a colon, which is the two dots, one over top of each other. And sometimes we simply put the word 2 between the two numbers so that we are comparing one to another. So let's think about what that could look like in terms of this statement. I walked 6 miles in 2 hours. Yay, good for me. Maybe I should actually do that today. All right, so this could easily be a comparison. I am comparing the fact that I can walk. Let's do it this way. I can walk 6 miles in 2 hours. There we go. That's it. That's a ratio right there. 6 compared to 2. 6 over 2 written as a fraction. As said before, I have other options. I might write 6 colon 2. And I'm comparing 6 to 2, writing it this way. Or I might actually just write 6 to 2. And that's another way to write it. So these are all ratios, just taking two numbers and comparing. We're comparing how far I can walk in the amount of time that I actually walked. Comparing two things. All right, now, the fact that these have units are interesting. So let's actually take it a little farther besides just calling it comparing 6 to 2. What if I reduced this fraction? What if I combine this idea with the idea of reducing fractions? Let's see, 6 over 2. 6 over 2, I can divide that by 2 and divide that by 2, which means if you're good, we're dividing by 1 in the form of 2 over 2. Either way, we're saying that we're taking a factor of 2 out of each of these, leaving us with 3 over 1. And so this means that I did a 3-mile walk in 1 hour, and now all of a sudden, because I've reduced it, I've got a 1 in my denominator, and because I have units, now we go beyond just calling this a ratio, although it is still a ratio, but we also call it a rate. This just really says that I'm walking 3, do you know how that goes together? Miles over hours. What's a word that means division? Miles per hour. 3 miles per hour. So per indicates the division, the comparison between those two. So what are we saying then is the difference between a ratio and a rate? Not much. Rates are ratios, but they tend to have units. And usually they will also have a denominator of 1, like we see right here. All right, so two concepts we've already kind of tied in together. We've got this guy right here. All right, that's our ratio, and this is our rate. And when we see any of the numbers written in a form like this, so if we see just two numbers with a fraction, or with the colon, or with the word 2, all of these things we would usually refer to them as being ratios. All right, so that's what a ratio would look like. But as soon as we simplify this and we put units with it specifically, because this original sentence actually meant something, it was in context, this is what we would call a rate right here. This guy is a rate. He's also a ratio, but because we simplified it, denominator of 1, units, miles per hour, units, miles per hour, denominator of 1. There we go. These would be referred to as ratios. These would be referred to as rates. How you doing so far? Okay, maybe, kind of, sort of, hopefully. All right, let's see if we can take this a step farther. And we're going to say that I have a friend. Ha, good for me. Okay, I have a friend named Jonah. I don't actually have a friend named Jonah. Sorry, I'm going to make friends with somebody named Jonah, apparently. All right, my friend Jonah walked 8 miles in 3 hours. Good for Jonah. 8 miles in 3 hours. Now, here's my question to you. Does Jonah walk as fast as I do? Do we walk the same speed, the same rate? Or does Jonah walk faster than me? Or does Jonah walk slower than me? How would I figure this out? There are a few ways that we could do this, all right? We are saying 8 miles in 3 hours. So if we think about that in fraction form, and most of what we're doing today is actually going to be in fraction form. So while we can use colons and the word 2, we're going to largely go with this right here. I'm trying to compare that to my fraction, which was 6 over 2, but otherwise known as 3 over 1. How will I figure out whether or not, so question mark, does this actually equal, where'd it go? 3 over 1. So if Jonah walks 8 miles in 3 hours and I walk 3 miles in 1 hour, is that the same? That's a question mark, by the way. Excuse me. So, ideas. Well, 8 and 3 don't really have a common factor. So if I could reduce this, it'd be really nice if I could reduce this and just compare them that way. So that actually is a good thought. If I can reduce a fraction, I can compare fractions that have been reduced. But this one doesn't reduce super well. Well, okay, so this is a fraction bar, but keep your options open. Think about wider perspectives here. That's also a division bar. What's 8 divided by 3? In other words, what I'm kind of saying is here, what if, give me a squiggle, I say 8 divided by 3, I'm going to kind of do a weird, well, you know what, I'm going to do less weird for the moment. I'm just going to stick to this. I don't want to scare anybody quite yet here. And I just do 8 divided by 3. That is going to be 2 and 2/3. 8 is to be 2 and 2/3. If you did that in the calculator, that'd be 2.66666666 for all of eternity. Okay, so that's a division problem. What if I divide mine? What if I do 3 divided by 1? Ooh, we don't need a calculator for that one, do we? 3 divided by 1 is 3. So if I'm trying to compare these two, I walk, according to this guy right here, I walk 3 miles per hour. And this division actually gives me the same sort of effect, but this is 2 and 2/3 miles per hour. Because essentially I've divided top and bottom by 3. I'm kind of going to the same thing here. So if we divide these and compare them, this number and this number are not the same. So if I asked you, again from before, does Jonah walk the same speed as I do? No, he does not. All right, very different speed there. Mine is 3 miles per hour. There we go. His is 2 and 2/3 miles per hour. Is Jonah faster or slower? Well, that's a smaller number. That means he's walking less miles in 1 hour than I am. So he is slower than me. There we go. Now, is Jonah actually slower than me? Maybe he is. Maybe he isn't. Maybe he got a leg cramp in the middle of his walk. Maybe he just stopped and smelled the roses. You never know. Okay? So, recap where we are right now. Ratios, compare two numbers. Rates, also compare two numbers, but usually with units. And if I want to know if one ratio or rate is the same as another, I can compare them by thinking about them as fractions and maybe simplifying. But if that doesn't work, I can go to division and say, hey, 3 divided by 1 is 3, 8 divided by 3 is 2 and 2/3. These are not the same value, so this is a faster speed, a faster rate, and this is a slower rate. Okay? How you doing? How you doing? All right. Next up, we have Pearl. And Pearl walked 4 miles in 1 1/3 hours. So, I don't know. Maybe you looked at this at the very beginning for Jonah and said, nah, he wasn't as fast. I could tell he wasn't as fast. What do you think about Pearl? Does she walk the same speed as me? Is she faster or slower? How would we find out? I would ask you to try to pause right now to see if you can figure that out. All right, so give it a second, pause the video, try to figure out what you think, faster, slower, or the same speed as me with my 3 miles per hour, and then come back to me. Ready, set, pause. And we're back. I hope you paused. I really hope you paused. This is the same kind of thing, saying, all right, We still know my speed. Mine is 3 miles per hour. But I'm trying to figure out if I do 4 over, and this is weird. Can I have a fraction and a fraction? That's strange looking. But if I compare 4 miles to 1 1/3, again, it's a comparison. It's a ratio. But because we're talking units, miles and hours, we refer to this as a rate, mostly. Except, again, usually we have a denominator of 1. This is 1 1/3. This is not going to simplify easily. But perhaps, again, I can just think about this as division. So keep the flexibility open in your brain. Yes, it's a fraction. Yes, it's a comparison. It's also division. So what is 4 divided by 1 1/3? You want to guess? It's 3. Weirdly enough, it's 3. 4 divided by 1 1/3. For any of you that likes fractions, let me take a small mental trip. This is the same thing as we were saying 4 divided by 1 1/3 as an improper fraction would be 4/3. How do I divide by fractions? Keep the 4 multiplied by the reciprocal, like this. And what's going to happen? Boom, and what's going to happen? Hey, check it out, 3. So whether you believe me or not, 4 divided by 1 1/3 is 3. That means that Pearl is walking 3 miles per hour. How did you do? Did you guess that? Did you figure that out? Pearl walks the same speed that I do. Her rate, her comparison, is 3 to 1, 3 miles for 1 hour. Again, Jonah was 2 2/3 miles for 1 hour, miles per hour. All right, so as kind of a preparation here for our next page, because I want to do one more example, I'd like you to fill you in on a proportion and what a proportion is. A proportion is going to be 2 ratios that equal each other. 2 ratios that equal each other. So this is the third thing on our topic list. So we talked about ratios, rates, and proportions. There's ratios, there's rates, there's proportions right there. 2 ratios that equal each other. So I sort of wrote that here, didn't I? I put 8 over 3 equals 3 over 1. But I put a question mark because is that actually true? Well, it turns out it wasn't true. So that's not going to be a great example of a proportion, but that's what a proportion might look like. The difference there is the word equal. I need 2 fractions, 2 ratios that equal each other, and that's going to make a proportion. So let's see what that kind of issue problem thing here might look like. One last example. I'm going to walk away from that. There we go. Jackson. I know that Jackson walks the same speed that I do. Notice I put in the word rate to go with speed because that's what a rate is. In this case, specifically, it is a speed. So Jackson walks the same rate or the same speed that I do at 3 miles per hour, but he's been walking for 6.5 hours. So how far has Jackson walked? This is a great time to test out a proportion. They're supposed to be equal, and we're saying that Jackson walks the same speed. So that means that these are going to be equal. So if we think about me versus Jackson. I walk 3 miles in 1 hour. Jackson, wait a minute. Let's think about this in units. What did I just do? That was miles, that was hours, right? So right now my fraction is set up. I have miles on top and I have hours on the bottom. This is supposed to be the same. Okay, this is supposed to be a proportion. They should be equal. So I'm actually going to put an equal sign right there because I know that these are supposed to be the same speed. If this is my miles and my hours, what do we know about Jackson? Well, he's been walking for 6.5 hours. Where is that going to go for Jackson's ratio? 6.5 hours. Miles on top, hours on the bottom. We're going to put that here. Can I do 6.5? Is that okay with you? If I do 6.5 as 6.5? Because 6.5 and 6.5 are the same thing. And the question becomes, how far has Jackson walked? So what do I not know? I do not know how many miles Jackson has walked. This is a proportion. All right? Put this here for you as a reminder. Proportion. There we go. Proportion. We are saying I have a fraction equal to a fraction. I have 2 ratios that equal each other. All right, well, this is a little bit crazy. How do I figure this out? How do I figure this out? Interesting. Can I jump over here for a second? it turned out that Pearl's and my walkings were the same rate. Yes, Pearl's and my walkings. Wow. One Take Studios, people. So I had originally, I'm going to go back to my original numbers, which said that I walked 6 miles in 2 hours. So I did 6 miles in 2 hours, and Pearl walked 4 miles in 1 1/3 hours. A little bit squishy, a little bit tiny. Mine was 6 miles in 2 hours. Pearl's is 4 miles in 1 1/3 hours, and it turned out that these really were equal to each other. Well, let me show you something sort of fascinating. Okay? If I were to, right now, multiply across, you've probably heard of cross multiplying, 2 times 4. 2 times 4 is 8. And again, I got that from multiplying straight across these guys, one to the other. All right, 2 times 4 is 8. What happens if I multiply the other direction? The other kitty corner from each other. What is 6 times 1 1/3? Well, believe it or not, grab your calculator if you want, that is also 8. So if I know that my two fractions are really equal to each other, I can multiply across one direction, multiply across the other direction, and get the same exact number. So I can use that over here because I know that they're equal, and I know most of my numbers, but if I multiply across one way and multiply across the other way, it should equal the same thing for both. What might that look like? Well, again, multiplying across one way, so I'm going to go 3 times 6.5 and multiply those guys. And I'm going to go 1 times m, I'm going to multiply those guys. So 3 times 6.5, multiplying the one direction, and 1 times m, multiplying the other direction. Okay. Well, let's see. Here's what I really like. What's 1 times m? That's just m. Check it out. There's my m by itself. If I figure out this value, I will know what m equals. I will know how many miles Jackson has walked. Can we do this? Can we do this? Let's see. 3 times 6 is 18, and a half is 1 1/2. That's going to be 19 and a half. Don't believe me? Let's see. What happens if I do 3 times 6.5? Oh, look, I checked on my calculator. See, boom, I'm right. 19.5 is it. That means that's my missing number. When two fractions really do equal each other, you can multiply one way, multiply the other way, and set those two things equal to each other, and use that to help you figure out missing values. All right. Again, this process right here, we often refer to as cross multiplying. So that's what we just did, is we were doing cross multiplying. And I think that's usually hyphenated. So there we go. Cross multiplying, multiplying across. So a lot of words here, a lot of numbers here actually too. But keep in mind that the concepts themselves are not crazy, but you do have to try to learn some vocabulary here. So a ratio compares two numbers. A rate also compares two numbers. It's a ratio, but usually the denominator is 1, and we're going to have some units to go with it. If I start taking my fractions, my ratios, and actually setting them equal to each other, that's when I get proportions. And when I cross multiply, I can figure out missing pieces, because if I cross multiply two fractions that are the same, I get the same value. Okay? Practice, 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 and I'll talk to you later. Thanks. Bye.